So what if I told you that a piece of technology, one you probably have in your pocket right now, is being used to solve a colossal industrial crisis? We're talking about taking millions of tons of just chaotic construction waste and turning it into a super pure, valuable resource for the green economy. This is the story of a digital refinery and how it acts as a kind of sentient bridge between two completely different worlds.
Okay, let's just jump right in. At first glance, yeah, you're looking at a modern smartphone. Totally familiar, right? But in the high-stakes world of industrial waste management, this thing has a completely different identity.
That's right. This is not a phone for scrolling social media. Nope, it's a seriously locked-down compliance gate. It is the very first line of defense in a system that's designed to stop multi-million-dollar contamination events and navigate an absolute minefield of environmental regulations. It's the exact point where the messy physical world of waste smacks right into the clean digital world of data.
So, how on earth does a phone become a gate? In this first section, we're going to break down the incredible on-device intelligence that makes this whole transformation possible, turning a regular consumer gadget into a powerful industrial sensor right there on the front lines. This right here, this slide gets to the absolute heart of the problem. It's what's called the visual fallacy. To you and me, the weathered wood on the left looks totally harmless, right? It looks just like clean pine. But the AI knows better. It knows that wood could be laced with invisible toxins like arsenic from pressure treatments. Just one single contaminated 2x4 can poison an entire batch of biofuel and potentially destroy millions of dollars of refinery equipment. This is a problem our eyes simply cannot solve. So what's the secret sauce? Well, it's the hardware and software working in perfect sync. This phone is running a modern AI-focused chip that's powerful enough and efficient enough to run sophisticated AI models like Gemini Nano right on the device itself. The whole thing is orchestrated by this LiteRT framework, which is kind of like a universal translator between the AI and the chip. And here's the crucial part. All of this happens in real time, completely offline, out in the mud and dust of a construction site where there's no Wi-Fi.
And this is where things get really, really smart. It shows you the system is so much more than just a camera. It's multimodal, it sees and it hears. So the AI might do a visual scan of a load of wood and say, yep, 99% sure this is clean. But then it processes the driver's spoken note that's attached to the file. And if Gemini Nano hears the trigger phrase deck demolition, it knows decks are almost always built with nasty pressure-treated wood. It immediately overrides that visual result and flags the entire load as high risk. That right there is the sentient part of the bridge in action.
Okay, so that's how the gate works. But that single device? That's just the very first step. It's the gatekeeper that feeds data into a much larger, way more complex system, the 5-layer digital refinery. This diagram shows you the whole shebang. The data from that phone starts a journey through 5 totally distinct layers. It kicks off at intake, where the AI makes its first judgment call. From there, the logistics module manages all the trucks, and a regulatory layer automatically checks everything against environmental law. Then that data flows to a financial layer for billing, and finally, a reporting layer proves everything is compliant and valuable. It's a seamless pipeline from a messy demolition site to the pristine inputs the bioeconomy demands. Now, a really key innovation happens in that financial layer: decoupled billing. See, instead of getting one confusing bill, the invoice is broken down. You've got logistics, weight, and this crucial one, the regulatory levy. All of a sudden, that financial penalty for contamination, let's say it's $60 a ton, isn't some hidden costs anymore. It's a visible, painful number that the client can directly control and even reduce to zero just by sorting their waste properly. It basically weaponizes financial transparency to change behavior. It's brilliant. Now, this is a fascinating concept, and I love it. It's called hostile UX, or intelligent friction. The whole point is to stop drivers from just going on autopilot when they're doing something critical. To finalize a load, the driver has to physically press and hold a button on the screen while the phone's haptic motor vibrates like crazy, kind of like the resistance of an old-fashioned wax seal. This tiny 2-second action creates this definitive, tactile moment that really reinforces the legal gravity of what they're doing, sealing the chain of custody for that load. And this table just puts it all together side by side. The old model was a total black box, one price with all the penalties hidden inside. It basically treated the client like a liability, and the cost was just this slow, constant bleed. The refinery model, it's all about transparency and optimization. It isolates the risk, that specific government fee, the CIRCIL levy, and it gives the client the power to get rid of it. It turns waste from a fixed cost into a variable they can actually manage. So we've seen this really elegant solution. But now, let's talk about the scale of the crisis it was actually built to solve. Because this isn't some niche problem. This is about the survival of a core part of Ontario's industrial economy and its ability to lead in this new circular bioeconomy.
Just look at this timeline. This shows what the industry is facing, a full-blown existential waste cliff. By 2026, cities stop collecting industrial waste. By 2029, it becomes illegal to send clean wood to a landfill. And by 2034, the regional landfills are projected to be completely, totally full. The old way of doing business is about to run full speed into a brick wall.
And the scale is it's staggering. When the current system finally breaks, this is what's left over. 4 million tons of orphan construction waste every single year with nowhere to go. This isn't a maybe, it's a mathematical certainty the industry has to solve, like, right now.
On top of that physical crisis, there's a financial one. Domestically, companies are about to get hit with that new CIRCIL levy, up to $60 for every ton of mixed waste. And for anyone who used to just ship their waste to the US, well, new trade rules and tariffs of up to 35% are slamming that escape hatch shut. It's a classic pincer movement of economic pressure.
But here's the brilliant reversal. This is what the client sees. The digital refinery takes that mountain of liability and completely transforms it into a carbon dividend. The dashboard shows them in real time exactly how much money they're saving by avoiding that levy. And even better, it quantifies the carbon their diverted wood has sequestered, which generates valuable carbon credits. It literally turns a cost center into a new revenue stream.
So let's bring this all home. Every scan, every data point, every override and financial calculation, it all culminates in one final critical output. An output that's designed to be an impenetrable digital shield in the harsh reality of industrial commerce. This is it, the 9-point certificate of origin. And look, it's not a fancy app screen. It's a high-contrast, fax-ready document. It's designed to be read by a border agent under crappy fluorescent lights. It has everything. Validated GPS, the atomic signature from an X-ray scan, the legal attestation for trade rules, an automated check against Ontario's waste rulebook, and it's all locked together with a cryptographic blockchain hash. This document is the ultimate proof. It's the digital shield that lets clean biomass cross borders without getting hammered by tariffs. You know, this whole operation is really a digital tightrope walk. The risks are enormous. An AI hallucination could lead to massive fines. A sensor that's miscalibrated could send tainted wood that literally destroys a reactor. But the rewards? They're an absolute game changer. We're talking millions in saved levy fees, new money from carbon credits, and bypassing crippling trade tariffs. In this game, data is the only safety net you've got.
And this quote, man, it just perfectly captures the entire philosophy here. It's a fundamental shift in thinking. You stop treating waste as a physical problem to be buried, and you start treating it as a data problem to be solved. Trash becomes a database. And when you're facing that waste cliff, it really is the only viable path forward for the 905 corridor to stay on top.
It really leaves us with a powerful question, doesn't it? This system created a sentient bridge between construction and the bioeconomy, all using a device we completely take for granted. So, what other huge, seemingly unsolvable industrial problems are just out there, waiting for the right data, the right sensor, and their own sentient bridge?